Okay, page 2, the final review. So again, this one, number 10, is just like the first page where we're solving exponential equations. Same idea, you want to get 25 and 125 to be the same base. All right, so I know that the one root of both of these numbers is 5. So I can change these to both 5. And actually, let's make a little bit more room since we have this little expression up there in the exponent. All right, and so 25 is also 5 squared, but then also include the exponent x minus 1 at the top. And for 125, 5 cubed is also 125. And again, include the expression up at top. And again, remember, any exponents next to exponents or on the outside, we multiply those. So here we're just going to distribute this 2. And that becomes 2x minus 2. And then again here distribute the 3. And this becomes 6x plus 9. And then same idea. Once the bases are the same, I can just cancel them and then solve the equation. So 2x minus 2 equals 6x plus 9. And what I'll do is I'll move the 6 over here. And so that means I'm going to subtract it. And I'll move the 2 over here, which means I'm going to add it. Remember, opposite sign there. All right. So then 2x minus 6x is negative 4x. And then over here, I've got 2 plus 9 plus 2, which is 11. All right, and then last step, divide by negative 4. And so x equals negative 11 fourths. And remember, we always want to bring that negative up to the denominator. I'm sorry, numerator, not denominator. All right, so number 11. All right, so I want to evaluate this. So this is rational exponents. In other words, an exponent that has a fraction. And so remember, we can convert this into a radical by, first draw the radical. That 36 goes inside. The number on the bottom becomes the index. And then surrounded in parentheses, and that number on the top goes outside the parentheses. So now what you want to do is do one step at a time. First, work out or simplify the inside. So square root of 36 is 6. And then we have the 3 out there. And then do 6 to the power of 3, which I believe is, what is that, 216? Let's do it real quick over here. Let's see, that plus that. Yep, 216. All right, and that's the answer there. Okay, next one, simplify. Okay, we're going to be simplifying a rational expression. So what we want to do is we want to factor, if we have an expression like this on the top with squared and one on the bottom, a trinomial, we want to factor that. So the top, remember, 2 numbers minus in the middle, this will factor to, if they're both perfect squares, I can square root them, x and 9 and 9, and then it'll be plus and minus. And then below, let's see here, this will be x and x, 2 numbers that multiplies to be 9 and 10. 9 times 10 is 90, and we'd have to have negative 10 plus 9 to get negative 1 in the middle number. All right, so I factor that out, and if you want, you could do the box with this as well. So x squared, negative 90, again, same thing, x in the box, so negative 90 goes up top, negative 1 on the bottom, and I figured out, oh, it must be 9 and negative 10, negative 10x, 9x, and so that, remember, those 2 numbers go in the box there, and then I get x, negative 10, 9, and then those are my same factors that I put over here, okay? And it's nice when remember, this is just a 1 in the front, I actually don't even need to do the box, because then it's just plus 9 and then negative 10. All right, so anyways, now we're going to cancel out any like factors. Well, we have x plus 9, and that's it. So then our final answer is x minus 9 over x minus 10. Okay. Next one, simplifying again. Now we have multiplication in the middle. So what I'm going to do is multiply across. Because remember, we have multiplication in the middle of 2 fractions. So I'm going to first do 4 times 6, which is 24. Then we multiply the variables that are the same, so, or like variables. So x to the fourth times x to the 1. Remember, if there's nothing there, it's 1. And remember, you add the exponents when you multiply. So x to the fifth. Then y times y cubed would be y to the fourth. And then the bottom, 3 times 2 is 6. And then I have x squared. And y to the fifth times y to the fourth is y to the ninth. Okay, so now what we want to do here, is first we want to simplify the coefficients here, the numbers. So 24 over 6, well, we can divide those. So 24 over 6 is 4, so I'll have 4 on the top. All right, now if I have 5 x's on the top and 2 on the bottom, that means these will all cancel, and I'll have 3 left on the top there. And if I have 4 on the top but 9 on the bottom, all the ones on the top will cancel out, and then I'll have 5 y's on the bottom, or in the denominator. So again, we had 4 on the top, 3 x's, so x cubed, and then on the bottom, everything canceled out except for this y to the fifth. Okay, next one. Now, a lot like the last problem, except in the middle, it's division this time. Zoom in a little bit. So with division, the first thing you want to do is flip the second rational. So as I flip, so first let's actually just flip it so I can show you what we're doing. I'm going to put the 3x plus 21 up there, x squared minus x minus 6 here, and then this stays the same over here. All right, now just like, let's see, what number was that? I think it was up here in the last page. Where did we factor? Oh, sorry, number 12. Number 12, we factored the numerator and the denominator. So we're going to do the same here. Okay, so factoring x squared minus 4, well, that becomes x, and these are both perfect squares, so square root both of them. 2 and 2, and that's plus and minus. And then I'm going to factor the bottom. X and x, what's two numbers multiplied to negative 14, add up to 5. Well, that'd be 7 and 2, and 5 is positive, so 7 has to be positive. Okay? But then don't forget, we also have to factor the other side. So here, I'm not going to factor like I would with like the x. Here I can factor by GCF. What's the greatest common factor between 3x and 21? Well, 3. Okay? And then I'm going to divide out a 3 here, so that just leaves us with x. And if I divide 3 here at 21, that gives us 7. And then on the bottom, again, we'll factor this again. So x and x, two numbers that multiply to negative 6, add up to negative 1. I think that would be, oh, not 6 and 1, but actually 3 and 2. And to be negative 1, negative 3, and plus 2. All right, so now we're going to scan across here and look for factors we can cancel. Well, first I see negative 2 and negative 2. And let me just use red because I like it. Root of negative 2, x plus 2, x plus 2, x plus 7, x plus 7. And that's it. The 3 and the x minus 3 are not like factors, so we're just going to rewrite it with 3 in the numerator and x minus 3 in the denominator. Okay, simplified. All right, let's move up to number 15. Oh, bouncer. Okay, so now we've got addition in the middle. All right, so with addition and rationals or fractions, let's take this back to elementary school a little bit. If we're adding two fractions and the denominators are not the same, well, we can't add them until they are the same. So what I would do is, on the right, I would multiply this times 2 in denominator and the numerator. And then on the left, I would multiply this times the opposite denominator and numerator. Okay, so that's 3, I multiply 3 here, and that's 2, I multiply 2 here. Okay, so I'm going to use the same idea here. So I want these two denominators to be the same, because here they would end up being both 6. Okay, so 3 over 6 plus 2 over 6. And then I could add them together, 5 over 6, right? So here, what would I have to multiply on the left and right in order to get them to be the same? Well, if I multiply this times 5, okay, well, then they both be 10. Okay. But now I want them, and I'll also multiply this times 2 so that they're both 10. But then I want them to share the same variable. So this side needs one more x so that they're both x squared. Okay, so now I'm going to multiply that out. So on the left, 2x times 4, 8x, over 2x times 5x is 10x squared, plus, okay, now we're going to distribute this 5, so 5x minus 5, and then we get the same 10x squared on the bottom. And now that the new denominators are the same, then we can add them up, or add up the numerators. Okay, so we're going to just combine them together here, and then we'll combine like terms. I'll bring our next step up over here. So we got 8x and 5x are like terms. 13x minus 5 over 10x squared. Now the last step you want to do is check to see, is there a common factor between, basically when it's not factored out, like the last problem, or lateral problems, we had factors on the top, like this, like x plus 2 and x minus 3 and x plus 2, and these are all combined with parentheses, right? Whereas this one is not. So you're going to look at each individual term here on the top and the bottom, and is there a common factor between 13, 10, and 5? No. And do they all have an x? No. So you can't factor that anymore. All right? But if there was, you could. Now solve this radical. Okay? One key step, I want to get rid of that radical, and to do that, I'm basically going to raise this whole side to the power of whatever the index is. Remember, if there's no index, it's 2, so I'm going to square it. And I'm also going to have to square the other side. Remember, do the same thing to both sides. When I square that radical, it will cancel out, and now all I will have left is the radicand, or whatever is inside. Okay, and then on the right, I have to square that, so that's 25, and then you get this nice easy equation. Okay, so then add 6. X equals 31. All right, and then remember with these problems, plug it back in, make sure it works. 31x minus 6 is equal to 25. Square root of 25 is 5, so we're good. Okay? Because sometimes that won't work, so make sure you plug it back in. Draw an angle that measures negative 230. Okay? Well, I don't really know exactly where negative 230 is. All I know is that negative angles go in the clockwise direction this way, right? But I don't know exactly where that's at. I don't know how far to go to get negative 230. So what I'm going to do is change this to a positive angle. And the way you can change that is add 360. Because wherever this angle is, if I add 360, it'll still be the same angle, just at a higher, more positive number. And so you can change an angle either by subtracting 360 or adding 360. Now I want it to be positive, so I'm going to add. So if I add 360 here, then I get, let's see, oops, sorry, I'm not doing this correctly. Actually, because they're different signs, I have to subtract them. So I'm going to put 230 below. Subtract here, 0 minus 0 is 0, 6 minus 3 is 3, and so 130. All right, so I know where 130 is, because 90 is here, 180 is here, so that means it's somewhere between here and there. All right, so it's about there or so, and that's all you need to know. All right, so if you get this angle that you're not really sure where it's at, because it's negative or maybe it's really big, change it into subtract 360 or add 360 until it's something you're more familiar with. Now give a positive and negative angle that is coterminal with 32. All right, well, we're going to use that same idea that if I add or subtract 360, that I will get the same angle that is coterminal. All right, so I want a positive and a negative. So to get the positive, add 360. So 32 plus 360, that's simply just 392. All right, so that would mean one full turn all the way around plus an additional 32. So actually we'll just go ahead and draw that all the way around and somewhere about right there, right? Because here's 32 to begin with. So all the way around that'd be 392. And to get the negative angle, we're going to do the same thing but subtract. Okay, so we'll do 360 minus 32, and then it will keep the negative sign. So let's borrow from here. So 10 minus 2 is 8. 5 minus 3 is 2, and then we bring down the 3. And remember, it has to be negative. So negative, and you can do it in the calculator if you don't remember how to subtract negative from a positive number. Okay, so now negative 328. And remember, it's the same point. It has to be the same point. Okay, except we went the other way. We went this direction. Okay, and so that is going to be negative 328. All right? And simply the most you really need to know is that if I want a positive angle, add 360. I want a negative angle, subtract 360. Okay? That was page 2.